This video is a review of our Chapter 4 concepts, congruence in triangles. So we're going to start by just thinking about what congruent means. Congruent means that it has the same size and shape, as another figure. However, it's important that we name congruent figures a certain way. For example, I have triangle ABC is congruent to LMC. They told me that. Because of the name, they've told me that triangle A is the same as triangle L. They've told me that angle B, is the same as angle M. And they've told me that angle C this way is the same as angle C this way. Now notice the tick marks, or the arc marks. One arc mark up here matches one over here. 2 on this angle matches 2 on this angle. So I could write this congruent statement another way, but there's also wrong ways I could do it. So I could say BAC, that would be doubles, single, triple. BAC is congruent to M, that's double, L, single, triple. I can say that because B goes with M, A goes with L, and C goes with C. But look at what I couldn't say. CAB, that would be triple, single, double, goes with CML, that would be triple, double, single. C goes with C, and that's great, but look at A. A has one arc mark. It can't go with M. M has 2 arc marks. So this would be an incorrect statement. So just the fact that you use the letters is not enough. When you use the letters, you're telling somebody what matches up to what. So please make sure when you write a congruent statement or look at one that you make sure you have the correct matching parts. Now another question you might get asked is, name the side included by A and B. Included by is another word for saying between. So the side that's between A and B is simply AB. Okay? So included by, when you see it, it means between those two. Name the angle included by CM and ML. So here's CM and here's ML. Which angle is between those two? It's angle M. Okay? And you might see clues in the names. CM and ML both have an M in them. Means they're probably sharing angle M. Okay? So first thing we had to think about was, how do we name these figures? The second thing we thought about was using those fancy theorems with their letters. Okay? So the first way we said how to find a congruent triangle was to show every single angle matched up to another angle and every single side matched up to another side. And that was, we had to list 6 different things, 3 sides and 3 angles. However, there are shortcuts, as we discovered. Because it turns out if you have a side, an angle in the middle, and another side, like this, there is no way to create a different triangle without changing one of those 3. So side, angle, side, or SAS, will give you a congruent triangles without having to name the other parts. And side, 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 angle, side, angle, 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 side, and hypotenuse, leg. Remember, hypotenuse, leg only works in right triangles. Okay? Only works in right triangles because other triangles don't have a hypotenuse. So how could I have hypotenuse, leg if they don't have a hypotenuse? I want you to make sure you pay attention to the order, because the order matters. So when I see a figure that says something like, prove ABC is congruent to CDA. Okay? So I'm given that A and C are congruent, and this side over here and this side here is congruent. So I say to myself, which one of these theorems could I use? I have a side here, and I have an angle here. So I either need another angle or another side. And hopefully you see that side going right down the middle, right? That's my other side. So if I were asked to prove this, the first thing I would say is just write all the given down. Okay? And that gave me a side and an angle. And the second thing I would do is say, oh look, I can use AC because it's in both triangles. AC is congruent to AC, reflexive property. Okay? Now I have an S, an A, and an S, and I'm ready to say this. That first triangle is congruent to the second triangle. Why? SAS. Every time you're proving a triangle, you will end with one of these theorems. Every time. Okay? If you have other parts that don't make up these theorems, you can't prove triangles. It's that simple. Okay, what do we look for that they don't mark? I just showed you one. If you have that shared part down the middle, yay, that's another side. Sometimes you're going to have a shared angle. Okay, but in either case, if something is shared, if it's in both triangles, we will use the reflexive property to show that this side equals itself, or this angle equals itself. Okay, so that's the first thing we'll look for. The second trick to look for is vertical angles. So anytime I have the crisscrossy lines going on, they don't have to tell me those angles are congruent. I'm supposed to know they're congruent. Okay, so look for vertical angles and look for a shared part, and that'll give you that extra side or that extra angle. Now, some of you are using CPCTC as a reason that the triangles are congruent. It stands for corresponding parts of congruent triangles are congruent. That's only to use after you've told me they're congruent. I can't say that the reason they're congruent is because congruent triangles are congruent. That's the kind of strange logic. Well, the reason he's tall is because he's tall. I can't use that. I have to use this CPCTC after I prove it's congruent. So it never proves triangles, it proves parts. So for instance, if I asked you to prove two sides in a triangle congruent, first I would use angle, side angle, or side angle, side and prove the triangles are congruent. Then I'd say, oh, by the way, those sides are in the triangle. So corresponding parts of congruent triangles are congruent. That would be the step after I said triangle A is congruent to triangle B because of side angle side or angle side angle. So please make sure you go back and look at your notes if you don't quite get that and see that that's a separate step. Proves parts after we prove that they are congruent triangles. Now we spent some time on isosceles triangles because they have some terrific properties that will help us out. The biggest thing about isosceles triangles to remember is if the sides are congruent, it proves that the angles are congruent. So for instance, because these two sides are congruent, the angles opposite them have to be congruent. Okay? And I also know that, see how I have an angle here and an angle here? That means in the big triangle, this side must be congruent to this side because that they have their base angles are congruent. So these are some properties that we're going to be able to prove. So this is the vertex angle. It's the one that's not got a pair of angles. These are the legs. They're always the ones that are congruent and have the tick marks. This is the base. It's not always on the bottom, but it's always the one that doesn't have any congruent sides. And the base angles are found right here at the bottom. Okay, so when we refer to those. So we can use a picture like this and solve what are the angle measures. Well, I have a triangle, so I know that A plus B plus C equals 180. That's why I always will start. Then I noticed they gave me 50, so I put a 50 in here. But look what I did with B and C. I changed that to 2x. If this is x right here, this is the same thing, right? So don't I have two x's? So I put a 2x right there. So I subtracted the 50 and got 130 and divided by 2, so x equals 65. This angle is 65 and this angle is 65. Oh, by the way, so is this one because it's got an arc mark on it, 65, 65. Okay? So how would I measure angle E? Well, the exact same way I figured out the ones from angle A. I would say, well, gosh, if this is 65 and this is 65, couldn't you add those together and subtract from 180 and find out what E is? That whole 180 degrees in a triangle is going to be huge. Okay? Now, one last thing about isosceles triangles, they're symmetrical, right? They're symmetrical and beautiful, and therefore, if I cut one down the middle, if they say they bisect a triangle, bisect the vertex angle of an isosceles triangle, it will always make a right angle here and cut this in half. Always. It makes two perfect halves triangles. Okay? How do I know it was bisected? Look for these marks up here. That tells you that it's the same angle on both sides. If you don't have that, if you just have a line coming straight down and they don't tell you or show you that it's bisected, then you can't do this. But if it's bisected, it'll bisect the bottom and it'll make a right angle. By the way, if it bisects the bottom and makes a right angle, it proves that it's bisected the top because you have a perfect little cut in half symmetrical triangle. Now after isosceles we got a little bit tricky. We got to some more difficult problems. These overlapping triangles can sort of confuse us a little bit. One of the best strategies in dealing with them is separate them. Okay, so I'm redrawing this and I drew all the the letters in to make sure I knew what was what. And what they really want to know is ZW congruent to XY? So I put a little mark here for myself for ZW and XY. That's what I'm trying to prove. Now, I can't prove that sides are congruent until after I prove the triangle is congruent. So my first step is to prove the triangles are congruent. So I'm looking for parts, right? I see I have an angle here, right? And I have an angle here. And then I notice, I think they both have WX in them. See it? WX, WX, they share that. That must be my side. So I would write that, given the two angles, WX equals WX because of reflexive. The triangles are congruent because of ASA. Therefore, ZW is congruent to XY because of corresponding parts of congruent triangles are congruent. After I showed you that these two triangles are identical, then I can start pulling out parts and say, and this is the same, and this is the same. Okay, so that's the step. If you're asked to prove a part, first you're going to prove the triangles, and then you're going to prove a part. Now, some of you asked about a hard problem that we did in class. So we're going to do this one together. In this case, I was given that two triangles were congruent. I got to start with that. But then they're asking me about a part. And I pulled the two triangles apart and I got this. Now this is me marking all the corresponding parts that are true. And they're true because it was already given to me. So I marked those two triangles up. But then I noticed CE is up here. It's not even part of either of these two triangles. It's like some random thing in the middle. So I had to redraw and I pulled the two little baby triangles out of here. That's what I have to use. So I wrote my triangles that included those letters in it, and I looked at them and I went back and said, but you know, AC is congruent to BD, so I marked that. They gave me that in the triangle. And I know that angle A is congruent to angle B, so I marked that. And now I got a side and an angle, and look at these magical things. Vertical angles, that's my other angle. So I have angle, angle, side. So I would write first my given, and then I would write my vertical angles. Okay, and then I would write that these new triangles are congruent. This triangle is congruent to this one because of angle, angle, side. And if these two little triangles are congruent, then those two line segments must be congruent. And what causes that? After I prove the triangles, CPCTC tells me that the pieces are congruent because the triangles are congruent. So this was very complicated because I started with congruent triangles, but then I had to redraw and use the parts that were congruent in new triangles, prove those triangles, and then see that I have now the congruent parts that they were asking me about. Okay? I don't even think there's one this hard on the test, but this is probably at the hardest level that you would have to deal with in this chapter. Okay? So, of all the things that we've talked about, what you need to do is go back, do practice problems, make sure you understand on your own how to find corresponding parts, how to prove triangles congruent with our theorems, how to use CPCTC to find a part after you prove the triangles are congruent, and then how to use isosceles triangles and their properties to find different pieces that are going to be congruent. And last, how to take overlapping triangles, pull them apart, and try to figure out which parts are congruent so that I can still prove triangles or prove extra triangles after the fact. So the hard part about these is there might be several triangles going on at the same time inside that one figure, and that can make it tricky. But otherwise, I'm going to use all of the same theorems that I used before. I'm going to use all the same procedures that I used before, and I'm just going to work out and try to figure out the theorems and the proofs. Okay?